Nevada Test Site, 1957.
This is a review of Operation Plum Bob's military effects test results. Detonation-tested results, which fill out and extend the pattern of effects data gained over the past decade during Nevada and Pacific operations. The Plum Bob statistics can be recited briefly. This was the 6th Continental Test Series. 30 detonations were set off, early April to early October, among which were several non-nuclear safety tests. There were 43 military effects projects carried out by 21 government laboratories and agencies. To utilize our limited report time to properly emphasize DoD's most pressing effects problems tested on Plum Bob, we are regrouping the military tests into 7 objectives. These are protective shelters and underground free field measurements in high overpressure regions, basic effects in rugged terrain, radiation problems, especially neutron activation in soils, biomedical effects, aircraft structures tests, one following an aircraft-delivered weapon, pre-Pacific experimentation, individual field tests. The stage for the military effects operations was a long time in preparation at the test site, with the workmen and technicians subjected to all the vagaries of Nevada weather, which veterans of testing had long ago learned to link with atomic operations. Operationally, Plum Bob provided 2 new techniques for firing test devices to minimize the fallout hazard. One technique tested the feasibility of an underground detonation. This was the Rainier shot, placed 800 feet below the surface of a flat-topped mesa at the end of a 1,900-foot-long horizontal tunnel. The successful detonation of Rainier proved that a device can be safely detonated underground with a nuclear explosion completely contained and still permit necessary diagnostic measurements. Rainier's importance to the effects program included measurements of ground displacement and acceleration as a function of vertical and horizontal distance from ground zero, along with gross effects such as the extent of spalling in the tunnel walls. The second new technique was the utilization of balloon suspension for atomic device detonations, an altitude positioning technique which minimizes the fallout hazard by eliminating contamination from steel tower vaporization. Such a balloon shot was Priscilla, used to pinpoint a 700-foot airburst above Frenchman Flat against the bulk of DoD's effects experimentation. The most extensive effort on Priscilla concerned the study of basic effects in high overpressure regions, the collection of air blast and ground shock data needed to establish practical design information on protective structures. The pattern for basic nuclear effects was fairly complete at pressure levels where the overpressure does not exceed 50 pounds per square inch. Plum Bob extended this pattern to overpressures up to 200 psi, both above and below ground. By D-Day -1, the vastness of Frenchman Flat gave little hint of the effort expended, especially between ground zero and the 50 psi area. There was the usual scattering of basic effects recording instrumentation, supplementing the PT gauges, the Q gauges, the Wiankos, and other field-tested instrumentation of past operations, was one new device. This was a sharp-nosed supersonic head gauge, designed to do a better job of reporting the dynamic pressure for high-pressure regions than was done by the standard blunt-nosed pitot tube. At close range, there were 2 35-foot span concrete arches and 7 domes above ground. 5 of the domes were of 50-foot diameter reinforced concrete. 2 were of 20-foot diameter aluminum. Several of these structures were jointly instrumented by DoD and the Federal Civil Defense Administration. But at various depths under the surface, with soil cover tamped back into the original compaction of the Nevada earth, were many more structures of assorted shapes and materials, as well as related experimentation, all instrumented for their role in the protective structures program. Beyond the high overpressure range, amid animal stations, missile traps, and other testing paraphernalia, were test structures which had survived blasts during the upshot knothole and teapot operations. Once again, they were instrumented for blast and response. This time, to be subjected to a greater blast and shock loading than they had previously endured. This sampling indicates the scope of blast effect studies laid out and arranged around Priscilla 0 point, indicating these curved surface structures to be an efficient type for use in the high overpressure regions at least up to 70 psi. The three responding domes of 6-inch thick concrete suffered more damage than expected. The one at 88 psi was practically a total loss, while the dome at 42 psi had its windward side caved in. There was no damage to the one at 21 psi. The aluminum response domes, with skin thicknesses of 1/2 inch and 1 inch respectively, and instrumented to measure deflection, were virtually destroyed. The response of all domes was greater than expected because the unit loading coefficients of the curved dome surfaces were much higher than predicted. Basic to the underground program were these holes, drilled to gain free field blast information on the motion of ground produced by the air-induced shock in the high-pressure region. The holes were instrumented from the surface to a depth of 200 feet for acceleration, displacement, stress and strain at varying distances from ground zero. There was a large decrease in acceleration with depth between the surface and 10 feet. But between 10 and 30 feet, accelerations did not decrease to the extent expected. This unexpected result is believed to have been caused by peculiarities of the soil. Evidence of support rendered by deep vertical columns was indicated by acceleration measurements at both the top and bottom of 100-foot concrete piles compared to adjoining free field readings. At the ground surface, the free field acceleration was up to 70 g. 100 feet down, it was 5 g. Yet both at the top and bottom of the piles, the acceleration was 5 g. For underground stress measurements in the high-pressure region, steel drums, capped at each end with flexible aluminum drum heads of various thicknesses, were constructed. Placed at different depths and orientations at stated intervals from ground zero, the drums, simulating buried structures, recorded soil loading. Among the results was the finding that a large decrease in stress occurs between the surface and a depth of 2 feet. The underground structure program, testing concrete and steel arches and conduits as shelters, was very successful. 4 reinforced concrete arch structures of 16-foot span, with arches 8 inches thick, were placed 4 feet below the surface and backfilled at various ranges from ground zero. The arch structure closest in, 20 feet long, received 190 psi ground surface overpressure, sustaining a maximum permanent deflection of 1/2 inch with only minor floor cracks instead of the collapse expected. The concrete arch structure tests proved the excellence of this type of construction for use as underground protective shelters. Design assumptions were shown to be more conservative than necessary. Furthermore, these structures can be lengthened without limit and be capable of withstanding air blast overpressures of at least 50 psi. For the evaluation of buried conduits as personnel shelters, 12 commercially available steel and concrete conduits of 3 types, all approximately 8 feet in diameter and 20 feet long, were exposed at various distances from ground zero at depths of 5 to 10 feet. All the conduits had small circular hatchways and had unattached end walls of heavy timber. All the conduits survived the airburst in structurally serviceable condition, despite being subjected to overpressures up to 153 psi. This qualifies all the conduits as adequate for DoD Class 1 protection against 100 psi overpressure. Other underground structures tested were earth-covered prefabricated steel arch ammunition storage magazines, 25-foot span by 48 feet in length, for use as personnel shelters. 2 of the 3 magazines were strengthened with steel ribs, and all had strengthened end bulkheads. With the arch crowns 1 foot below ground level, each had an additional 4-foot earth berm covering. All of these corrugated structures survived in serviceable condition. The strengthened magazine withstood 100 psi with only minor floor cracking. The unstrengthened magazine was virtually undamaged at 56 psi, although collapse had been predicted. These gin bottles formed an integral part of a test in which a method using frangible backfill was investigated to provide protection of underground structures from the ground shock. In this experiment, an inner steel cylinder 2.5 feet in diameter was separated from an outer concrete pipe by a shear barrier of rubber cording. Around this assembly, the bottles, packed in sand, formed a special frangible backfill. These structures, simplified models of launching sites, were vertically placed in 15-foot holes at the 220 and 100 psi level and instrumented for acceleration. The post-shot results indicated that use of such frangible backfill can reduce by a factor of 4 or more the peak accelerations of any underground structure under the same conditions. Another major DoD objective on Plumb Bob was the study of the effect of rough, hilly land on the blast wave. The action took place 25 miles north of Frenchman Flat, where a 700-foot shot tower, the highest ever used, was constructed at the base of a line of hills. This was the Smoky shot, utilized to measure basic nuclear weapons effects on rolling and steep terrain compared to flat land. It was a study of what the rough terrain does to blast and radiation characteristics as the wave passes, and of protection afforded by terrain features, with jeeps used as response gauges. 4 blast lines were set up: a flat terrain reference line, a line of low rolling terrain to a height of 100 feet, and 2 lines crossing large hills of differing slope. The highest peak on these lines was 550 feet above ground zero. Earlier HE and nuclear shot tests in the low-pressure region showed shock waves considerably modified by slope, with an increase in peak overpressures on the uphill side compared to level ground, and a decrease on the downhill slope. On the rolling terrain line compared with the flatland line. The rolling line overpressures were generally all greater than the flatline pressures, except at the most remote station, where they were lower. At 2,210 feet, rolling hill overpressure was 23 psi, compared to flatline overpressure of 13 psi. The small hills and dales between 2,000 and 4,000 feet ground range showed little effect on the overpressures. In comparing steep hill overpressures to those on the flat line, recordings showed the hill overpressures to be higher than the flat line on the front slopes and lower on the back slope. As far as dynamic pressure is concerned, no true comparative figures between the rolling and flat lines were obtained, because the rolling line received a limited precursor, while the flat line received a strong one. However, enough information was gained to confirm that dynamic pressures are higher on hilltops than in dales. On the steep slope line, the dynamic pressures on the uphill side were slightly lower than the flat line. At the 550-foot peak, where an unexpectedly high overpressure was recorded, the dynamic pressure was well below the flat line, and on the back slope, it fell abruptly below those on level terrain. In the military vehicle blast damage study on Smoky, the most significant finding was that jeeps behind a bluff or mound suffered greatly reduced displacement or damage. The rolling and steep terrain effects study added an important segment of effects information vital to military operations. A third DoD Plumb Bob objective was a series of radiation studies, most important of which was a problem of increasing concern in tactical field operations: neutron-induced soil activity from fallout-free low airburst bombs. Both samples of representative soils and pure soil elements were exposed to the neutron flux from potential tactical weapon types. In addition to documenting the actual induced fields generated, measurements of the gamma activity induced in the exposed samples permitted identification of the significant elements which contribute to this effect, as well as evaluation of the gamma fields which would be generated over soils of varying composition. The results achieved confirm that aluminum-28, sodium-24, and manganese-56 are the primary radiating isotopes at early times, with sodium and manganese still significant beyond 1 hour. The induced activity was observed to be primarily generated by thermal neutrons, but higher energy neutrons also contributed. The moisture content of the ground also increases the intensity of the fields. For soils rich in these elements, the dose rate levels of the order of 1,000 Roentgens per hour were found to exist to distances of about 500 yards at H plus 5 minutes. In soils with a low concentration in these elements, the induced activity was found to be of little military significance. Foot soldiers traversing the ground zero area of a 10-kiloton very high neutron flux weapon detonated at 500 feet over Nevada soil would sustain about 200 Roentgens at H plus 1 hour. If the crossing were delayed to H plus 10 hours, this dose would be reduced to 40 Roentgens. In a continuation of the overall shielding studies of military vehicles and fortifications, neutron and gamma attenuation measurements were made on M48 tanks, Ontos vehicles, foxholes, personnel shelters, and machine gun emplacements. A portion of the radiation effort was also devoted to the tests of newly developed dosimetry and radiac equipment. Neutron flux and spectral measurements were made to obtain basic neutron dose information, with samples withdrawn from contaminated areas by cable. For events Wilson and Owens, the measured neutron dose values exceeded those predicted for high neutron flux weapons by factors of 2.5 and 4, respectively. Neutron measurements were also made to obtain flux and spectral information for use in interpreting the soil-induced activation results. These balloons were used to support instrumentation at various altitudes up to 1,000 feet to measure initial gamma dose and dose rate. Identical instrumentation was exposed at ground level, directly below the balloons. The results obtained show that the gamma dose gradually increases with altitude to reach a value of 30% greater than ground value at a height of 400 feet. Between 400 and 1,000 feet, no increase was evident. The ratio of free air dose rates at 950 feet to the dose rates on the surface remained constant over the 5-second interval for which measurements were made. The average ratio was 1.35, which is in good agreement with the difference observed in corresponding total gamma dose measurements. Change of gamma radiation mean free path with time is evident. Similar measurements of neutron flux as a function of altitude show that the more energetic sulfur neutrons increased with altitude to a value of 25% greater at 500 feet than at the ground. Data on variation of neutron dose with altitude, however, was inconclusive. The next plumb bob military objective, biomedical testing, was extensive on plumb bob. The major portion of the experimentation was devoted to furnishing information on the effects of nuclear weapons on a large biological specimen, the pig. Early in the plumb bob operation, 135 pigs in aluminum containers for protection against blast and thermal were exposed to the Franklin shot to determine the effects of combined neutron and gamma radiation and straight gamma. Franklin's extremely low yield made it necessary to repeat the experiment on shot Wilson. Wilson's higher than expected yield, along with a neutron line not shielded as well as Franklin's line, gave the pigs a greater radiation dose than desired. With only 2 animals living beyond the 30-day observation period, the relative biological effectiveness of neutrons was not obtained. On DoD shot Priscilla, 710 pigs were stationed at overpressure ranges of 10 to 1.4 psi in an arrangement to obtain a wide selection of combinations of radiation, thermal, and mechanical injury effects. The 4 midline stations were glass-fronted to serve as missile sources to obtain wounds for medical and surgical treatment evaluation. After the fury of the Priscilla burst had spent itself, a round-the-clock operation was set in motion, beginning with biomedical teams hurrying in to recover the animals. Of the group exposed within the precursor range, the primary cause of death was mechanical injury to the organisms due to translation. The mortality rate, nearly 100%, can be applied to man. Outside the precursor, those animals in the open which escaped total missile injury survived temporarily until the massive radiation they received took its fatal toll. Flying glass fragments did not significantly influence overall mortality. In the range where missiles produced a considerable number of wounds, most of the animals received lethal doses of radiation. Many in this group also received serious thermal burns. Due to the small number of survivors with the desired thoracic and abdominal wounds, evaluation of the medical and surgical treatment phase of the experiment did not produce conclusive results. By the time all the follow-up analyses of the various parts of the biomedical programming have been completed and collated, a considerable fund of knowledge will have been gained which can be applied to the treatment of field casualties after an atomic burst. A second biomedical project continued the eye protection experimentation begun on Operation Upshot Knothole. This was the field testing of a new protective device for the eye, a high-speed electromechanical shutter, tested both from aircraft and a trailer station. Comparison with the new shutter was made through viewings of the bomb flash by human volunteers using inoperative shutters and rabbits with eyes unprotected. Triggered by a detector sensing the presence of an unusual illumination, this electromechanical shutter provided complete protection against flash blindness and chorioretinal burns. It will now be incorporated into a goggle for service testing. In the aircraft structural effects program, the flight pattern of the delivery aircraft was found to have a marked effect on the gamma exposure received, and in particular, the exposure received during the interval of closest approach to the fireball was a significant portion of the total dose. In addition to the F-89 tests, the Plumb Bob Aircraft Structures program tested several Navy aircraft. Positioning and tracking was accomplished with a modified M-33 ground radar system housed in trailers on a peak overlooking Yucca Flat. The Navy blast response experimentation took in both overpressure and gust velocity effects, with participation in more than 6 detonations for each type aircraft. The Navy's FJ-4 and A-4D jets were tested for air-to-ground delivery of nuclear weapons. Both were small, rigid aircraft with short structural response times. In both the FJ-4 and the Delta Wing A-4D Skyhawk, particular attention was directed to the possibility of predicting transient gust responses. Results included pressure survey information on the wing, leading to an analysis of the diffraction loading, which appeared to contribute a significant portion of the theoretical loading on the A-4D. Overall, sufficient data were obtained to confirm the low-yield weapons delivery capability of the A-4D. The 2 remaining Navy projects involved unconventional aircraft, the HSS-1 helicopter and the ZSG-3 airship, both concerned with delivering nuclear anti-submarine weapons. Structural testing on the 2 craft leads us into the next Plumb Bob effects objective. On Plumb Bob, the structural response effects on the helicopter and airship were emphasized, preliminary to next year's Pacific shallow water burst when the input data will be obtained. Through exposure to 8 Plumb Bob detonations, the helicopter's critical overpressure limits were defined, with orientations not only head-on and tail-to, but also side-on. At the distance the helicopter operated from the burst, nuclear and thermal effects were negligible. All helicopter test results apply to the comparable Army model, the H-34. On the ZSG-3 airship, preliminary plumb bob effects analysis indicates that the envelope and ballonnet response to shock inputs appear to be the critical elements. However, further study is required before adequate conclusions can be drawn. Projects were also concerned with preliminary experimentation for full-scale tests in the next Pacific operation. These rockets and balloons are associated with a hardtack shallow water burst, proving out air blast measurement techniques. At altitudes below 1,000 feet, self-recording pressure gauges were suspended from tethered balloons. Above that altitude, parachute-held canisters containing pressure gauges were deployed by means of rockets. In a series of ground tests on plumb bob, a specialized set of gamma and neutron instrumentation was found to perform satisfactorily in the electromagnetic signal field when proper shielding was provided. This instrumentation was tested out for use on the high-altitude shot at hardtack. However, it was found that instantaneous telemetering of data from the ionized sphere produced by the detonation was not feasible. The data must be stored and transmitted at a later time. Weapons effects testing on plumb bob also included many other projects, each with an importance of its own. Here are a few of them. These anti-tank mines were among the 15 types of live and inert United States, NATO, and Russian mines tested in an extensive minefield clearance study project on the Priscilla shot. Preliminary results from the investigation of the behavior of pressure-actuated mines under nuclear blast loading were gained from a number of specific objectives. In a mine fuse study, it was found that 3 influence-type mine fuses tested appeared to be relatively invulnerable to nuclear blast. An ordnance project ascertained the neutron and gamma effects of a nuclear detonation on the performance of 2 types of guidance systems for the Nike Hercules missile. One, a vacuum tube version, the other, a transistor guidance package. It was found that transistor packages failed at all exposure levels to an extent that would cause loss of missile control at time 0. Another project received radio signals from an A-4D jet aircraft transmitting prearranged frequencies from behind a nuclear cloud to investigate the cloud's effects on the propagation of the signals. A group of receivers 10 miles from ground zero measured the approaching aircraft signal from 30 miles beyond to within 4 miles of the ionized cloud. Measurement of the attenuation of frequencies in the region from 4 megacycles to 9,245 megacycles, from H plus 1 minute to H plus 6 minutes, showed no reduction in the strength of the signals from the aircraft. This study measured electromagnetic effects. With the detection gear placed close to ground zero, measurements were made of the magnetic component of the electromagnetic signal emitted by a detonation. Another project, which utilized detection stands in Oregon, New Mexico, and South Dakota, further studies of the capability of a long-range detection system were conducted. The project investigating thermal protection for the individual soldier tested uniforms, flash burn cream, and various shielding materials under atomic fire with shaved pigs used to approximate human skin. Results on the uniforms were relative. 2 experimental uniforms, given a fire retardant treatment, stood up better than a non-treated uniform currently under consideration for field use. The flash burn cream tested provided protection up to 25 calories per square centimeter. Shielding materials gave some protection to both uniforms and skin, where sufficient space between the shield and the protected item existed. This concludes our rundown on the major effects experimentation on Operation Plumb Bob. The studies on basic effects measurements and protective structures in the high overpressure areas provided the information necessary to accomplish reliable design and construction of required types of protective structures, both above and below ground. The Smoky program, comparing effects on rolling and steep terrain with level terrain values, filled a gap in the pattern of basic effects knowledge which the military had long wanted. The neutron induction experimentation and associated radiation studies confirmed the early time hazard of induced activity and added more knowledge in the field of initial radiation. The extensive biomedical program obtained vital information on a wide selection of blast, thermal, and radiation effects. The results, together with casualty care techniques tried out during Plumbob, will contribute to programs dealing with the mass care of nuclear casualties. In each of the aircraft structures studies of the F-89 Interceptor, the FJ-4 and A-4D Navy jets, as well as the HSS-1 helicopter and the ZSG-3 airship, areas were explored in which either the margins of safety were critical or the aircraft configurations were different from previously tested types. Some projects gave preliminary tests to instrumentation slated for full-scale use on the hardtack shallow water and high-altitude shots. Data obtained on other projects, embracing such studies as thermal protection, landmine tests, and measurement of electromagnetic effects, will contribute materially to the reduction of susceptibility of military equipment to the effects of a nuclear detonation. This was Plumbob's Military Effects Operation 1957. Its contributions, a valuable extension of previous effects information, and vital as a base for future findings.